A very good morning, class. Today we are going to start VSEPR theory, that is valence shell electron pair repulsion theory. We have done that how the structure will be can be found by hybridization. Yes. So now we will understand about the regular and irregular geometry of that, and that we can call as a shape also. Okay. So let me explain the shape of the molecules. What does it mean? Shape of molecules, it is the definite relative arrangement of the bonded atom in a covalent molecule. That is also known as geometry of the molecule. That means it is a definite relative arrangement. एक दूसरे atom के respect में whatever the definite arrangement will be there, that is called shape of the molecules. Okay, and that is also known as geometry of the molecules. So what are the main feature of this VSEPR theory? Let me explain that. According to this, it says that the shape of the molecule depends upon the number of electron pair which will be shared as well as non-shared. That means which will be bonded as well as the lone pair of electrons around the central atom. The electron pairs around the central atom tend to repel one another since the electron clouds are negatively charged. If lone pair of electrons are left over there in the central atom, so they tend to repel each other. Okay, and since electron clouds that is negatively charged, so due to this negatively charged, they repel each other, and due to that the shape get distorted. Okay, so let me explain that. The electron pairs in the space tend to occupy such position that they are at the maximum distance apart and the repulsive interaction will be minimum. So lone pair जो होते हैं in the space, they try to acquire such space where the inter electronic repulsion will be very less, and hence the molecule will be stable. Okay, the structure will be stable. So if we talk about the repulsive order of repulsive interaction force, so then the lone pair and lone pair repulsive force is the maximum. Then it will be little lesser lone pair and bond pair repulsion, and the least repulsion will be there in the bond pair repulsion. Out of these three, if the combination are there, so this will have the least repulsion force. Okay, repulsive force over there. Now another thing, on this basis, if we see that VSEPR theory, the covalent molecules can have two types of geometry. They can have two types of geometry. The first geometry will be called regular geometry, in which it will be surrounded only with the bonded pair. There will be no lone pair of electrons. Okay, so then it will give you the regular shape, regular geometry. Got it? If they are having, or there is only bonded electrons, yes, or we can say that the bond around the central atom, then it will have a regular geometry. But if the central atom is surrounded with either bond pair with the different atoms, or both bond pair and the lone pair are there, got it? Either different elements, like on one side chlorine is attached, another side fluorine is attached, third side some other element is attached. So in that case, okay, or if there is bond pair and a lone pair of electron are there on the surrounded atom, then the geometry will be different. Why it will be different? Because of electronic pair repulsion. Got it? So it says that geometry becomes like, if they are not same, they will not be mutually balance each other. They will not be able to mutually balance each other, and due to which the geometry of the molecule will be distorted. Okay, so this is the same line here written. I have written, if the central atom is surrounded with the either bond pair with different atoms, or with bond pair and lone pair. In this case, repulsive interaction in such molecule do not mutually balance each other. Alag-alag honge, so obviously they will not be able to balance each other, and that's why the geometry of the molecule will be distorted. So how it is? Let me explain with some examples. So here few examples I have written. The actual shape, in the actual shape, this is a point you have to learn. In the actual shape, lone pair of electron do not participate. Okay, so structure, so to make it clear, what I'm going to explain the few things, like don't be confused in the shape and the geometry and the structure. See, if structure it is asked, structure will be depend upon the hybridization. Okay, simple hybridization bit. While if we will take the shape or the geometry, if we'll talk about the shape or the geometry, we will not consider the lone pair in this case. Lone pair won't be considered. Okay, this is the key point you have to keep in your mind. Let me explain with the help of example. Like suppose SO2. So I think you can draw the direct bond structure now. Yes, you are able to do that. If I'm taking let's do with the hybridization first. If I'm doing with this hybrid orbital, so what it will be, hybrid orbital, that is TVE plus minus charge upon 8 होगा यहाँ पे, because hydrogen is not there. So total valence electron is 6 and 6 plus 12 upon 8, isn't it? That is 18 upon 8, and that means there will be 2 bond pair. The completely divisible will be bond pair, and the rest जो भी बच जाएगा उसे 2 से divide करोगे, that will give you the lone pair of electron. So 2 left, 2 divided by 2 यानी कि 1 lone pair. So 2 plus 1 will be the 3, यानी कि hybridization जो होगा that will be sp2, isn't it? And if we talk about sp2, then the structure will be trigonal trigonal planar. Yes, so can I write like this structure if I'm talking about, and this is the coordinate bond. I think you people are very clear with this, because sulfur has 6 electron, so it has it made the covalent bond over here by sharing the 2 electrons. Yes, and here only it has donated. So what about the lone pair? Will there be any lone pair? Yes, of course, 1 lone pair is there. So due to this lone pair, so lone pair structure will be on the 3rd. That means if we talk about that, the structure will be triangular planar. Yes, triangular planar is structure somewhat like this. This is the, you can see, and another is like here. Yes, let me make it like this. Okay, any problem? This is the structure, and on this the lone pair is there. So if I don't have to consider the lone pair in the shape, so just forget about it. Which type of shape it is? Now think of it. Is it a bent? Yes, so yes, it is a bent. So we'll say that shape will be bent, or you can say V shape. I hope it is clear, bent or V shape. Any problem, bache? Yes. So now we will consider about the ammonia, NH3. Similarly, find it hybrid orbital if you will find. Let me do it in short. This is nitrogen in 5, 5 plus 3, 8, 8 divided by 2, isn't it? It will be 4. Clear? So it is completely divisible. This and NH3 and H2O is little like there is some exception accordingly, because it is completely divisible. So it is supposed to make 4 bond over here, but यहाँ पे सिर्फ 3 bond मिले, because 3 atoms are there. Slave atom or substituent atom, if you are talking about, it is only 3. So it can form maximum 3 bond only. Okay, although it is completely divisible with this, but it will make the 3 bond only, because it doesn't have the atom here. So hybridization, if we'll talk about, it will be sp3, isn't it? And sp3, that means tetrahedral. Structure will be tetrahedral. And if we draw the tetrahedral structure, it will be like this. N, here it is H, here it is H, H, and this is the lone pair. Okay. So see, this is in same plane. Ye bond, ye or ye same bond mein, same plane mein. And this one is little above, like this. Okay. So if you will forget about this, agar ye lone pair ko bhool jate ho, suppose that this is the structure. Let me draw this in this way, 3D way. If I am making like this structure, did you get it? Lone pair bhul jao. So is it a pyramid shape? Isn't it? It's a pyramid shape. So we will write the shape or geometry is here, pyramidal. Hope it is clear. Yes. And since this is an important point, so let me keep it in box. Okay. Now next, H2O. So let's do the same way. H2O is also having hybrid orbital 2, hybrid orbital 4. How? H is 2 and oxygen is 6, so 2 plus 6, 8, 8 divided by 2, it is 4 only, completely divisible. But it can make bond only 2, yes? So we'll make the bond, hybridization, sp3, and what will happen, this is the structure will be tetrahedral, but if we'll draw the structure, how the structure will be, see, this is oxygen, this is hydrogen, this is hydrogen, okay? And here it will be lone pair and here it will be lone pair. So now again you just think of it, this is the bond for hydrogen, here hydrogen, this one is the lone pair and this one is the lone pair, okay? So what to do, isse hata do and isse hata do. So you are getting the shape, yes, it's a bent, okay? The shape will be bent, or you can say that the V shape, okay, or V shape. Any problem in this? Okay, this one is the, don't be confused in this, this is, and here it is, this is for H2O. Now SF4, we will do for SF4. So SF4, sulfur is having like valence electron 6, 6 plus 7 4 ja 28. So 28 plus 6 34. 34 divided by 8, it will be 4 bond pair and 1 lone pair, isn't it? Are you getting like this? Think of it. Sulfur 6 and 7 4 ja 8. So 8 28 plus 6 34. 34 divided by 8, 8 4 ja bond pair completely 2, and 2 divided by 2 1 lone pair, isn't it? So total is 5. That means hybridization we are getting sp3d. That means the structure will be trigonal or triangular भी बोलते हैं कहीं, trigonal bipyramidal. Yes. Okay. So now it's time to draw the structure. So let me draw the structure. Sulfur is here, trigonal bipyramidal. The structure is like this, isn't it? ये रहा. And this is the bond, isn't it? Now we have one lone pair, so this is the extra like odd one, so we will keep the lone pair over here. Any problem in this? Okay. And all this 4 position, the fluorine will be here, fluorine, fluorine, fluorine. So we don't have to take this, we don't have to consider this lone pair. So which type of shape is this? Just think of it, it is like this, yes, and here it is like this, isn't it? So ye kya dekha hoga, in the park you have seen, this is the seesaw, isn't it? Seesaw structure. So that's why this is called seesaw structure, shape, seesaw shape. Yes, I hope it is clear. Now ClF3, it is important. So we will do ClF3 later on, because here the space will be congested. So we will do, and it is a special one, you have to learn this, okay? We'll do later on. Let me explain the ClF5. If I'm doing the ClF5, I will cut it from here and let me write over here ClF5. Yes. So check this. The lone pair, the total valence electron of chlorine is 7, and here 7 5s are 35. 35 plus 7, 42. 42 divided by 8, it will be 8 5s, isn't it? Hybrid orbital. 8 5s completely divisible, or what is that? 2 divided by 2, 1 lone pair, isn't it? So 1 lone pair. What is the hybridization? sp3d2. 6 है ना total. So this is octahedral. Okay dear. So ये that you have to learn. ये learn नहीं होगा, you will not be able to do this. Okay. So you have to learn this. If the hybridization is this, what will be the structure that you have to learn? Okay, so octahedral. Let me draw the octahedral structure. This is the octahedral structure. If I am doing, this is Cl, and here this one and this one. Let me use another pen, otherwise it will be mixed with this. So how many fluorine bond pair? 5 bond pair are there. So 5 at 5 places we will keep the fluorine over here, and at one place there is the lone pair. So at one pyramidal shape we will keep the lone pair over here. Done. Now check this. This is the square. Okay. one bond is upside and another bond is downside. तो एक pyramid ये हुआ square. Can we say that one pyramid on upper above the surface and one pyramid below the surface? Can we say if it is sp3 do octahedral? Can we say like this? So since one is not participating, so there will be only one pyramid, isn't it? So then what will be the shape? It will be square pyramidal, not bipyramidal. Octahedral को हम square bipyramidal भी कहते हैं, but the shape will be only square pyramidal. Why? Because lone pair doesn't participate in the shape, actual shape. Got it, बच्चे? Okay. Now XEF4. XEF4 is hybrid orbital. If we'll find hybrid orbital, XE8 and 7 4 are 28. So 28 plus 8, 36. 38 divided by 8, it will be 8 4 ja, yes, complete bond pair, and 4 left, 4 divided by 2 यानी कि 2 lone pair, isn't it? So what is this? 6. 6 का मतलब क्या हो जाएगा? sp3d2. That means its structure is also octahedral. But what about the shape? If we will draw this shape, this is C. XEF4, let me draw it over here. XE, and this is 4 here, isn't it? So it is having 2 lone pair, isn't it? So we will keep the lone pair at that place where the repulsion is minimum. So these two are the at the far distance. So we'll keep the lone pair over here, one lone pair and another lone pair over here. Okay, and at all 4 bond we will keep the fluorine. So what happened now? Upside and downside दोनों lone pair है, that is not going to participate in the actual shape. So only this square is left, isn't it? So what will be the shape? Square planar. I hope it is clear. Yes. Any problem in this? And the last question which I left earlier. So let me explain that. The last structure is, let me draw with this ClF3. This is the most asked question and very important question. Okay, ClF3. If we will find the hybridization for this, so let's find it. Hybrid orbital, that is 7 plus 7 into 3, 21 plus 7, 28. 28 divided by 8, it will be 8 3 bond pair and 2 lone pair, isn't it? Yes or no? So total is 5. That means hybridization is going to be sp3d. Yes. And if the sp3d is there, then the structure will be triangular or trigonal bipyramidal. Yes. Bipyramidal. Any doubt in this? Okay, let me use this. Okay, so trigonal bipyramidal. So now if we'll draw the shape in general, तो कैसे बनेगा? See, this is the trigonal bipyramidal. Let me draw it like this. Yes, and in the center chlorine will be there, and here like this. So 3 fluorine. So what we will do in general, we say that these two are same and these two axial are same and these 3 equatorial are same. So 3 elements are there. So we will keep this 3F over here. And यहाँ पे हम रख देंगे lone pair, isn't it? If you will draw like this, it will be considered as wrong. Why? See, fluorine being more electronegative, what they will do, they will repel each other. तो ये एक दूसरे को ऐसे repel करेंगे, जिसकी वजह से क्या होगा? ये पूरा का पूरा bond ही टूटने की chances होंगे. Got it? So the compound, the molecule is not going to be stable. So we will keep in such a way so that कि सारा रिपल्शन जो हो वो थोड़ा मिनिमाइज हो जाए एंड शेप भी बहुत ज़्यादा मतलब बॉन्ड ब्रेक ना हो, डिस्टॉर्ट हो जाए, इट्स ओके, बट बॉन्ड ब्रेक ना हो. ओके, सो व्हाट वी विल डू, यू हैव टू कीप इन योर माइंड दिस स्ट्रक्चर इज वेरी इंपॉर्टेंट एंड दिस विल बी ट्राइगोनल बाइपिरामिडल लाइक दिस Cl, and what we will do, instead of putting lone pair in on this axial, we will put the lone pair over here. ये lone pair हम रख देंगे. So now you will say that कि ma'am, right now you only said that lone pair repulsion is maximum, isn't it? So why not here also maximum होगा? तो क्या होगा फिर? तो कुछ नहीं. This is the electron cloud. If they repel each other, then also the will be little distorted. The bond is not going to break, isn't it? And both, all the three fluorine will be at this position. So इसकी वजह से क्या हो गया? They will have the maximum distance, isn't it? It will have maximum distance. I hope it is clear. Yes. So in this case, अब ये क्या होगा? Due to this, this is also not the actual one. होगा क्या? Due to this repulsion, electronic repulsion, ये इधर की तरह repel करेगा, ये इधर की तरह repel करेगा, जिसकी वजह से क्या होगा? That fluorine is going to little distort from its position, and the fluorine will be like this. Here it will come. So the actual shape अगर हम बात करेंगे तो this will come like this, somewhat chlorine, and this is fluorine over here, this is fluorine over here, and this is the fluorine over here. That means it is going to be bent T shape. Okay, अगर ये सीधा ऐसे रहता and ऐसे रहता तो it will be T, yes, but here it is little tilted, isn't it? So this will be called bent T shape, and it is very important, as I told you. If you write that trigonal planar or something else, कुछ भी लिखोगे, even T shape में भी थोड़े से chances हैं marks कटने के. So you are supposed to write bent T shaped. I hope it is clear. Yes. So this is this is all about the VSEPR theory. We will practice more questions. I will give you the extra questions for practice, and that's it for VSEPR theory. Next theory we will do the bond parameters. So till then, thank you class.